Hello, everyone. I'm Pavol Mederly, and today I will tell you what's new in tasks in MidPoint version 4.4. We'll talk about the new conceptual model for tasks and activities. Then we'll cover new style of task definition, various improvements and new features like auto-scaling, thresholds, bucket analysis, and execution reports. And finally, a few words and a small demo about migration. Tasks are with us from the very beginning. They undertook a couple of major functionality boosts over the time. The multi-threading was added in 3.1, clustering in 3.8, and lightweight partitioning in 4.0. These features have been working reasonably well. However, some of them were quite hard to use. Their configuration was complex and their runtime manageability was limited. About a year ago, we got an idea how to rework the tasks and we went for it. We have devised a completely new model of task definition and execution. And it soon became obvious that the new model doesn't only cover existing features, but it provides new, originally unforeseen options. Let's have a look. The new model is based on the concept of activity. An activity represents the work that needs to be done. Let us explain that by looking at so-called simple activities first. A simple activity consists of an action, like here, recomputation, carried out on a set of objects, like all users in a repository, for example. And this is it. Yes, this is something that was called a task. Or other common types of simple activities are, for example, import from resource, live synchronization, creating a report, running a script, scanning for object triggers, or even special no operation activity that is useful mainly for demonstration and testing purposes. And these activities operate typically on MidPoint objects that are coming from either from repository or a resource. But some of them may deal with other types of items like audit records, synchronization events, or even lines in a file or simple numbers. Besides simple activities, there are composite ones. They consist composite because they consist of sub-activities or children, we may say. Usually they are predefined in MidPoint, like the most well-known is perhaps reconciliation that involves first completion of unfinished operations, then taking resource objects and synchronizing them into MidPoint, and finally going through shadows that were not touched in the previous sub-activity and somehow dealing with them. And these three sub-activities are bundled together and called a reconciliation. Another very typical and common example is cleanup activity that consists of cleaning up tasks, notes, cases, report outputs, certification campaigns, and audit records. The concept of composite activities is crucial for the reporting on their execution. For example, the progress of such activities is no longer a simple number. Now it consists of an information from each of the sub-activities. Also, some configuration elements need to be attached not to the activity as a whole, but to individual sub-activities, like bucketing is a typical example. And besides those predefined composite activities, we now have also custom ones. Such activities contain customer-specified children. So, for example, you can define a composition of a recomputation of all users here, followed by, let's say, execution of a Groovy script. or by creation of a defined report, or basically anything you would like to. You can also, for example, combine reconciliation of 3 distinct resources into one activity if you need to. This composition mechanism is really powerful. This feature is currently considered to be experimental. It doesn't mean that it would not work, quite the contrary. But there are some aspects like the UI that are still not quite fine-tuned to represent custom composite activities to their full extent. Therefore, the experimental status. The new model allowed us to radically simplify definition of tasks. Let us have a look. This is how the task definition looked like before version 4.4. We used generic and extensible structures like extension, handler, URI, and object reference. This was, yes, really dynamic and flexible and immediately open for customer extension. But for the engineer, the configuration was definitely hard to write. For years, I have struggled with finding out the correct handler URIs or making sure that I use the appropriate extension items in my tasks definition. In version 4.1, the UI support got much better with the use of archetypes, but this didn't help those of us that write task XML directly in an editor. In particular, the configuration of cluster tasks, like the one you see on the screen, was so complex that, for example, I was literally not able to write any from scratch. The only way for me was to copy and adapt a suitable existing task. And this is the new style. Everything about the work that has to be done is in one place, namely here in the work container. The structure is described fully in the schema. So, for example, in MidPoint Studio, you immediately see all the options you have, as we will show in a moment. The extensibility has been preserved, though, using the traditional schema extension mechanism. Overall, it's easy to read and easy to write as well. And the difference is even greater for complex tasks like the clustered ones. The activity definition has the following logically organized structure. The main part is the work, here the yellow one, telling what has to be done and on what objects, like importing all accounts from given resource or recomputing specified set of users using given execution options and so on. Then there's the execution mode. There are a few options like full, preview, dry run, or even none, meaning just fetching the objects. The distribution part here tells about how the work should be distributed into worker threads or worker tasks, buckets, and whether auto-scaling should be applied or not. And the control flow section here can be used to specify error handling strategy and also to enable or disable the whole activity or individual buckets or objects. Reporting is crucial for tasks. Here we can configure logging, new execution reports that we will show later, or tracing. And finally, the tailoring is used to configure these 4 aspects for sub-activities of a predefined composite activity, like for parts of reconciliation. Let me show you now a very short demo how you can write task definition by hand in MidPoint Studio. So here we are. So we are going to create a new task. So let's start task. Give it some ID. Let's create, for example, a user recomputation. The owner ref is obligatory, so let's do that. Let's make it administrator. The execution state is recommended, so runnable. And now let's go for the work. So activity, and first the work. Here we have about 20 options. that are known to MidPoint. So let us select the recomputation. And here we know all the options or all the configuration items that are relevant for recomputation activity. So let's select objects. And this is a standard structure. So we have to provide a type, user type. And we could select some subset of users using query and so on. Let's not do now. And imagine that we want to make this task multi-threaded. So we can start writing this distribution worker threads 12. If we would like, we could now configure, for example, buckets or workers, but let's not do that here. So here we have fully functional task written in the matter of seconds. Okay, let's get back. Okay. I have mentioned buckets. What are buckets? Many of you are already familiar with this concept, but let me describe it very briefly for all of us. A task, any task, works like this. It obtains a defined set of objects, like all users in this case, by issuing a query against a repository or a resource. Then it receives those objects and processes them either in single or multiple worker threads. But if we want to distribute the processing across the cluster, we need more worker tasks executing independently on each other. So we have to split the whole object set to smaller pieces that can be retrieved individually by the tasks. And these pieces are called buckets in MidPoint. Worker tasks then, well, they can allocate and process those buckets. And the buckets are typically described by choosing a discriminator property, like typically OID for repository objects, or a name or some kind of identifier for resource objects. And then, having a discriminator, we specify the way of division or of bucketing, typically, for example, for names by some boundary characters. So here, first bucket contains all accounts starting with A, then B, C, D, and so on, and for Z. With a slight simplification, but basically this is the schema. And then we say here that let's assume we have 2 nodes. So we say that we want 1 worker per node. And so MidPoint creates 2 worker tasks, and they start competing for those buckets, allocating and processing them. Now let's have a look at what specific improvements we have in 4.4. They are concentrated in the area of visibility that was a pain point, a real pain point in the past. The first improvement is that now we have precise measurements of progress, number of items processed, and throughput. The progress tells us how far we have got in the task up to now. So, for example, if we have 100,000 users, we can see that, well, about 35,000 of them have been processed by now. In the UI, the exact number is not shown, but it is known to MidPoint and can be seen in the data. The UI, well, just a matter of comment, the UI shows buckets processed by default. But this is not important. The important is that progress is how far we have got in the work up to now. Items processed, on the other hand, is a count of objects that have been fetched and processed. Isn't it the same as progress? Well, not necessarily. If you suspend a running task and then you resume it, the processing is restarted at the boundary of buckets. So objects that are in incomplete buckets are simply reprocessed. Therefore, you might be at the progress of, say, 35,000 users, but in fact, you might have processed 36,000 once. And so the progress is shown here in the summary panel, and items processed is here in the operation statistics panel. So the difference is users that were processed twice or generally multiple times. And finally, the throughput is the ratio of items processed, so this number, per time unit. So we have to know, or MidPoint has to know, exactly how much calendar time was spent running the task. And in 4.4, we precisely record these times, so we know that, except for recurring tasks where this would take simply too much space. So we do not evaluate throughput for such tasks now. In the future, we might even provide some estimation of time to complete based on this information, but well, it's a matter of some future versions. Cluster tasks execute in so-called task trees. You have a root task that spawn its children, potentially at multiple levels, so children, grandchildren, and so on. And those are distributed on the cluster nodes. Before 4.4, this meant that in the list of tasks where you see only the root ones, we were not always able to display complete information about the progress or error count. There are many Jira issues on this. In the current version, though, we are storing the key information right in the root task. So the execution state here, the number of worker tasks cluster-wide here, the progress, and the error count can be reliably displayed in the task list. So you no longer have to open such a task to see this kind of information. And now let's have a look at the most important new features. When you start a cluster task, it automatically starts the workers on cluster nodes according to what you specify in the task definition. However, if you add new nodes to the cluster, the task does not automatically create new workers. Now, you can do that either manually by clicking on the reconcile workers action in GUI. Well, this action has been available since 3.8, but in the current version, it was improved and made again more reliable. And there is also a new option now, automated scaling. You can start a special task that will watch for cluster changes and adapt all cluster-wide tasks to those changes by starting on suspending their workers. Note that there's a slight limitation that if you change the task definition manually, meaning you increase or decrease the number of workers per node, in such situation, you have to do the scaling also manually. This might be improved in future MidPoint versions. But the cluster changes, like starting or stopping a node, are reflected, can be reflected automatically by such a task here. Another feature is so-called cluster-wide thresholds. Sometimes we want to stop a task that starts doing unexpected actions before it's too late. For example, you generally do not want your reconciliation task to delete half of your users, do you? Such a thing is maybe not likely, but it is not impossible either, especially if you have source resources that sometimes behave incorrectly, providing, for example, no data to MidPoint. MidPoint allows you to set up limits on defined actions like object addition, object deletion, or specific kinds of modifications on items that you provide. So you can tell MidPoint, for example, that it should not delete more than 10, 50, 100 users during the execution of given task. You write this using a policy rule, such as this one, wrap the rule in a role, such as this, and then assign such a role to the task. After the threshold is reached, the task is automatically suspended. Well, there are two modes of operation here. Either this one, we can call it run then count, where we execute the task and count the events as they occur, or the other one is count then run, where MidPoint first simulates the execution, and only after making sure the thresholds are not exceeded, it runs the task fully. In MidPoint 4.0, the counters were held in memory, so this feature was limited to a single node task only. Now we maintain the counters in the tasks, so we support also the cluster tasks. There's an experimental feature that might be useful for troubleshooting performance or other issues related to task execution. MidPoint now allows reporting on the execution of tasks at various levels for buckets, objects, ConnId operations, or even internal MidPoint operations. This feature is rather trivial to configure, but allows a high level of flexibility if needed. Let me just show you very quickly how such reports look like. This is a report at the level of buckets. We see here bucket number, the content of bucket, generally given as some interval from 2 of a value of some identifier. Then how many objects were really in that bucket? How many of them were successfully processed? How many has failed, and how many were skipped? Then start and timestamp and the duration in milliseconds. You can display this in raw form or import this into spreadsheet application and draw a chart, and you can immediately see any irregularities or issues here. You can, for all those reports, you can select which rows should be put into that file or which columns are you interested in. The flexibility is quite high there. The same can be seen at the level of individual objects. Here is the object number, some kind of identification of the object, bucket number, and the outcome, success or skip or failure, start and timestamp, again, duration in milliseconds, and error message if any. Well, this level of report usually should be enabled only if really needed. And when you have real problems, for example, with a specific resource, you can enable reporting even on the level of individual ConnId operations, like getting an account or modifying an account, deleting, and so on and so on. So here is an example, again, some identification of an object. The resource in question, object class, the operation, and some timing information. Finally, this is for really deep investigation. You can record even the execution of individual MidPoint operations, almost at the level of Java method, but well, a little bit above them. So we can see, for example, that the invalidation of cache entries, which is the method invalidate cache entries here, of this object, of this OID, and so on, some additional data. It took 69 microseconds, and it was a part of processing of user with account name of Stan. This report provides really tons of data, so there are flexible configuration options to limit both objects that you are interested in, individual operations, columns, and so on. Now for another, maybe even more useful kind of report that's called bucket size, or this feature is called bucket size analysis. When executing a task in a cluster, it is very important to do the bucketing in such a way that your buckets will have the right size. For example, if you create too few of too large buckets, you will get inefficient distribution to cluster nodes, because maybe if you have 4 buckets overall, then your workers will basically have nothing to do if you would have, well, let's say 16 workers. Also, you will get rough information about percent completed, because currently the percent completed for bucketed tasks is shown as a percentage of buckets that are done. And also, if you suspend and restart the task with large buckets, there will be many objects that will be reprocessed. On the other hand, though, if you create many small buckets, you get large overhead with their management, because there is some overhead allocating and closing those buckets and so on. And this includes also the competition among worker tasks for those buckets. There is some database retries and so on and so on. Furthermore, in the case of uneven distribution, meaning a lot of small buckets and few very large ones, you can get the situation in which some of the workers finish very soon, and the remaining large buckets will be processed by 1 or 2, say, long runners. So the clustering will be ineffective. Therefore, we often like to see the real size of individual buckets. There are 2 options here: either exposed by requesting the bucket report, running the task, and then looking at the report afterwards, as we have seen, or ex ante by analyzing the buckets before the execution of the task. The analysis before execution can go through all of the buckets, or only through a given sample, which can be much faster. Imagine you have millions of users. To do that, you simply configure 3 things. Bucket level report here, and say you set execution mode to bucket analysis, and if needed, you select the sampling mode. Here we see a regular sampling taking 10 sample buckets to examine. There are other options. You can use random sampling by sample size, by probability, or even you can use custom expression to select buckets for analysis. The results then can be shown in a chart like this. This is from real, well, this is from performance testing, MidPoint 4.4. We can see that here we have 1 large bucket, so probably it will slow down the processing, and this was actually the case. So we might need to adapt the bucketing to avoid such a situation. A word of warning: beware, some resources do not support object counting, and object counting is what is used here. So we need to either turn appropriate configuration option on the resource on, or if there's none applicable, we have to go with really fetching the objects in the execution mode of none here. So there are ways to work around resources that do not provide counting. There are other interesting new features that would deserve description, but well, let's skip them for now, just a very brief mention. Since 4.3, there is a mechanism to very simply reprocess failed objects. It can be done either in a separate task execution, or, especially for live synchronization, there's a mechanism to automatically resynchronize errored accounts using so-called synchronization triggers. There is logging configuration. You can define custom logging options to have a log record after each bucket or even after each object is completed. You can choose either brief or full information there. In future, we might even implement complete overriding of logging configuration for a given task, just as it's currently done for tracing, but for tasks it is not done now, but could be. Third, the tracing is a way of diagnosing functional or performance issues. Some of you may know it. In 4.4, you can specify taking traces in tasks in a very flexible way. So you can tell MidPoint, for example, to take a detailed trace of operation on each 100th object and brief one each 10th object, or to record a trace for each failed object, or for each object that took longer than given time. There are basically custom expressions that you can use to drive the process of tracing. Sometimes it can be useful to have a way to skip processing of selected buckets or items. Well, it's assumed to be, well, not a regular way of operating, but sometimes that could be necessary. So the feature is here. You can write a custom expression, so-called precondition, that makes the bucket or object being processed or being skipped. Now a few words about the migration. If you have simple tasks, meaning tasks without bucketing and clustering, those will work with new MidPoint without changes. The multi-threading is okay in this respect, though multi-threaded will work as well. But we strongly recommend migrating even the simple tasks, because the UI is adapted to display the new definition. So legacy tasks will work, but they won't be displayed nicely unless you switch the whole UI to the legacy mode, but then you will lose many of the nice new features. And of course, if you have clustered tasks, you have to migrate them. They simply won't be recognized by new MidPoint. Also, the runtime state data structures has been changed significantly. So to avoid any problems, we suggest to re-import your tasks with the state information eliminated. There is one exception, and this is the live sync token and the scan timestamps. They are part of the state information. These two are migrated automatically by the new MidPoint. There's a detailed guide to migration in the docs, and MidPoint Studio has an option that will help with the migration. We will have a look soon. Just as an example, assuming you are running 4.0.4 or 4.3.2, so the process you already know. As far as tasks are concerned, before stopping MidPoint, it is suggested to suspend the tasks, and especially for multi-node, meaning cluster tasks, export the tasks, unless you have the tasks stored somewhere else, for example, in MidPoint Studio, which I would recommend, by the way, but if you have not them outside, so export them. Now, you will do the upgrade according to the documentation in standard way, and then you will start the MidPoint. And here are two options. Either you do the task migration in MidPoint Studio and you re-import them to MidPoint, or you simply resume them as they are, but you will see a lot of warnings in logs and some pieces of the tasks will not be shown in GUI. Let us have a look. I hope I have a running MidPoint. Yes, I do. So let me show you. This is 4.4, freshly migrated. So I have 5 tasks here. 3 are the standard ones. One is simple recompute task, and one is multi-node recompute task. If we open, for example, this simple recompute, we see that there's nothing here. We cannot tell if it's recomputing users or roles or what, and if there are some query or options or whatever. We just don't see. It is in the XML, but it is stored in the legacy format. we could see that, yes, it is here, extension, user type, and so on and so on. Okay, so let's do the migration. I have a studio here, and I have both exported tasks that are exported from 4.3, and I have also locally maintained tasks. So here is a task in 4.3 format, locally maintained. I will show you the more complex way, meaning migration of exported tasks. So here is a working directory that I will clean. I will copy the tasks, but I will leave out the system tasks, and also I will leave out the worker subtasks, because this cannot be migrated and need not be migrated. The only thing that should be migrated are our own top level tasks. So let's take these two, copy here. We do two things. First of all, because these tasks are taken from MidPoint, here is an option to clean up file. So we will do that. So we just cleaned up them. So it is cleaned up. Oh, the structure progress should be killed manually. And the second step is migrating them. We can do that again, either for the whole directory or individually. I will show you the individual migration. So after clicking upgrade task to activity, voila, the task is migrated. Oh, this was a some forgotten piece of data of runtime data. So it is. There are some namespace declarations that can be that are now unused, so can be cleaned up. You see new activity structure, and this one here it is even more interesting, because you can see the old style definition of work management, and all those handler URIs that are no longer needed. So let's do the upgrade. Again, some namespace declarations that can be thrown away. And we have migrated the tasks. So we will just upload them. We will no, I'm sorry, I forgot. Of course, we have MidPoint here, and we have tasks here. So let us first delete the old tasks. The children will be deleted automatically. So now no. Okay. And so let's do that. We will upload these two. And we will also upload the initial tasks. Okay. So looking at MidPoint now, here are tasks. These are closed because they were closed in the 4.3, so we can run them just to see they are working. So for example, this is the recompute. And now we see the new GUI can correctly display the configuration, the new converted, migrated configuration of the task. Fine. So we can close this and continue. Just going to conclusion. So tasks were radically changed in 4.4. There are usability and quality improvements and many new features. Please have a look, try them, and let us know. We are curious, especially about your experiences with the experimental features, just to know how to improve them or whether to throw them away if they are not useful at all. Everything should be documented, so please have a look at the docs. All of the work described today was sponsored from NGI Trust program, for which we are very thankful. There are 2 more webinars planned. The first one will be about UI customization and will be led by Katarina Bolemant. And the final one will be devoted to native reports given by Lukáš Škublik. Thank you very much for your attention. If you have any questions, you are welcome to ask.